Hello everyone, welcome to the world of data structure. Our today's topic is Introduction to Stack and Stack Operations. Hi, this is your instructor Janice Shah. So let's begin the today's outlines. Students, today we first understand that what do we mean by the stack, introduction to stack, then the various operations applied on stack. Basically, we apply 4 different operations on stack, that is push, pop, peep, and the last one is change. Students, we are going to see algorithm for push, pop, peep, change, how these functions are working, and how can you define the C function for push, pop, peep, and change algorithm. Fine. So let's begin with the first. What do we mean by stack? So what do you mean by stack, students? As we all know that stack is a linear data structure. Stack is a linear data structure. Okay. Why it is a linear? Because each and every element of the stack contains one predecessor and one successor element. Okay. That's why it's known as a linear data structure. Now, in linear data structure, when you have only one end for the insertion and one end for the deletion, then that data structure is known as stack. So, this stack is a linear data structure in which we are going to insert an element or delete an element from the stack only from one end. Students, that end is known as top of the stack. Fine. So what is the top over here? Top is a topmost pointer. Top is a topmost pointer which is used to point the topmost element of the stack. Another thing is that, students, stack follows the LIFO manner. LIFO, that means last in, first out. How? See, we all know that in this particular linear data structure, if I inserted something and if I am deleting that from the one end, then the element or the disk which I have inserted last, it becomes the first disk which I need to be deleted. Okay, so whatever the element you inserted last, it will be deleted first. That's why this terminology is known as LIFO, that is known as last in, first out, LIFO manner. Students, the insertion operation in stack is known as push and the deletion operation in stack is known as pop. So let's see the figure here, the 79, 80, 81, 82, 83. So this is a stack of disk. Stack of disk. That this example represents the stack. Now, if I can show you the stack in a real manner, then this figure. If you can see in this figure, the top pointer is starting is at the bottom level. Whenever you are inserting some element in the particular stack, the top pointer is increasing. That operation is known as push. And when you are deleting something from the stack, the top pointer is decreasing. That operation is known as pop operation. Fine. Why we are using push and pop? Push for the insertion and pop for the deletion purpose. Fine. So let's move towards the next. Our very first operations. How many operations are there on the stack? Okay. So the first one is push. Push operation, that means to insert an element in stack. Pop. Pop means a delete element from the stack. The third one is a peep. It means to fetch ith element from top of the stack. Okay. If this is the stack, if you want to fetch the ith element from top of the stack, then that operation is known as peep operation. See, peep does not delete any element. Peep operation always gives your element value but positioned at ith index. Fine. Now the next one is change. Last, change operation, students, is known as the change ith element from top of the stack. Okay, so how you can make a stack? Obviously we know in previous lectures the stack is nothing but but here we are going to represent the stack using array only. So students, this is my stack, the 10, 20 and 30, only 3 elements are there. Total array size is 5. Remember, stack size is 5. Okay, here I am representing my stack using array. Again and again I am repeating the sentence that here the representation of the stack is using array. Fine. So the students, 3 elements are there, the 10, 20 and 30, all 3 elements are there. Okay, so out of 5 only 3 spaces are occupied, 10, 20 and 30. Now students, just tell me where my top pointer should point over here. See, top is a pointer which pointing always topmost element of the stack, right? So here the topmost element is 30. The topmost element is 30. So my top pointer is pointing to 30 over there. Whenever inserting something inside the stack, students, that operation is known as push, and when you're deleting something, that operation is known as pop. If you can see the figure perfectly, that push and pop both operations occurred at only one end, and that end is known as top. So now let's begin with the first algorithm, that is known as push. Here if you can see something that is written over there, that procedure push as top x and n. So why this is procedure push as top s and n? Students, in algorithms, if you know the procedure that represents the algorithm return type, push is known as like algorithm name, and the parameters top, x and n. Fine. Now if you remember the function calling or function definition, there is written like this: return type, then function name and the function parameters. So as you know, when the function returns integer type value, then the return type must be integer. If a function returns floating type value, then return type must be float. But if a function does not return any type of value, then the return type must be void. That void represents that your function is not going to return anything. Same as void, students, we are using procedure over here. The procedure, the statement means your algorithm is not going to return anything. Fine. So here we are going to use two different keywords. The one is a procedure and second one is a function. If your algorithm is returning something, then it must be a function. If your algorithm is not returning anything, then it must be a procedure. Fine. So now is it clear when we need to use a procedure and when we need to use a function keyword? Now the next step is push. Push is our algorithm name, same as the function name, and the next are the key parameters of push algorithm. Students, S represent the stack. Okay, then top, whenever you have stack, you must have top pointer. So the top represents the top pointer, which is going to point the topmost element of the stack. X is the value that you want to insert inside the stack, and capital N represents total number of elements, or we can say size of stack. Fine. So N represents the total size of the stack, X is an element which we need to insert, top is the topmost pointer, and the S is a stack. Now what we want to do over here, we need to insert something inside the stack. Okay, so just understand very carefully, students. When we need to insert something, at the time during the insertion operation, students, we need to focus on the overflow condition. Why it's overflow? What do we mean by overflow? Overflow, that means you cannot insert the more elements in that particular data structure. So for any data structure, most probably, students, we are using overflow condition to check during the insertion operation that whether we can insert the elements or not. Fine. So here our first step number 1 goes like this: check for overflow condition. You have to write like this: step 1 in the brackets, write down check for overflow condition. Some of you may write like this: check stack overflow, is stack full or not. Okay, so you can write anything, but it must be relevant to your step. Okay, so here in the first condition we are going to check whether my top pointer is pointing at n or not, because if this is my stack, okay, my top pointer is pointing to the 5th position. If my stack size is 5, if my top pointer is pointing to the 5th position, that means all 5 elements are there in the stack and my stack is full, so I cannot insert more elements over there. That's why, students, my first overflow condition for the stack is if top is greater than or equal to n. If top is greater than or equal to n, then just write stack is overflow and return. See, here return is a statement. I am not returning anything, but return is a statement. Okay, I did not write return 0, return 1, return 2, return 99, return x, return y. No, I just write return. this return statement in algorithm shows that your execution of the program is completed from this step. Fine. Now let's take steps number 2. If your stack is not full, then what you need to do, students? First you need to increment the top pointer. You need to increment the top pointer and then assign the value. Okay, so how the top pointer is incrementing? The top pointer incremented like this: top is equal to top plus 1. Top is equal to top plus 1. So here instead of is equal to, students, we are going to use arrow. In algorithm, is equal to notation is used by arrow. Fine. So instead of is equal to, we are going to use arrow notation. So it shows like this: top arrow top plus 1, that means top is equal to top plus 1. So now your top pointer from 0 is now incremented to the 1, the first position, which is still empty. Now what you need to do is you just need to assign a value over there. You need to assign a value over there. That's why we can write s of 1 is equal to x. S of 1 is equal to x. But wait, here I cannot write 1, 2, 3, 4 because I do not know about the exact index of top. That's why to assigning a value, I need to write s of top is equal to x. That shows s of top arrow x. Fine. So students, s of top arrow x, that shows x is the element which is going to be inserted at the position top of array x, of array s. Fine. So the whole conclusion is s of top is equal to x. Now you have done with your insertion operation. So the step number 4 is finish. Just write return. Again, I am not returning anything. This return statement shows that algorithm is finished from this particular step. So what we did, isn't it very much easy? For the insertion operation, students, you just need to first check out whether my stack is full or not. How you can check whether my stack is full or not? You just need to compare the value of top pointer, like this: top is greater than equal to n or not. If your value of top pointer is matched with the total number of size of the stack, then it shows overflow. Now let's understand the algorithm better with the example. Fine. See, this is my current array 10 and 20. 1, 2, 3, 4, 5 are my indices. Again, I already told you that I have start my indexes from 1. So after inserting push 20, that shows the push 20 operation. After inserting the 20 value, my top pointer is pointing at 20. Now suppose students, if I want to insert 30 now, if I want to insert 30, okay, now just check, go in the algorithm and trace the algorithm first. Okay, just go inside the algorithm. Whether my top pointer value is 5, because the total line is 5, right? So whether my top pointer is at 5 position, no. Okay, so what we need to do? Move towards the step number 2. You just need to increment your top pointer. You need to increment your top pointer. So my top pointer value becomes 2 plus 1, that means 3. Fine. So our top pointer is 3. Now top pointer is increment, and then you need to insert the value, that is 30. So s of top is equal to x. So here we have push 30, where first top pointer is incremented from 2 to 3, and then 30 is inserted over there. S of 3 is equal to 30. So it goes like this. When I need to insert student 40 over there, then it shows like this: push 40 operation. Again my top pointer is incremented from 3 to 4, and I assigning the value s of top is equal to 40. So it shows like this. And the last step is 50, push 50. So that's a value. Now my top pointer is pointing to the 50. Now if I want to insert again, after inserting 50 students, if I want to insert again and go inside the algorithm, step number 1, check whether top is greater than equal to n, top value is equal to 5, condition matches true. So you cannot insert a new value because the stack is overflow. So it shows like my stack is full now. Fine. So this is how the push operation works on stack. Now let's move ahead with pop operation. Okay, repeat. So now let's move ahead with the C function of push operation. Students, how to write the C function? See, here I'm not going to return anything. That's why my function return type is void. Okay, First I am going to take integer array, integer as of 5, then top pointer as integer top, then integer x, and then integer n as the size of the array. After declaring all the 4 variables, I am going to start with my function. So my function is not going to return anything, that's why it becomes void push, okay, and I am not passing any variable. Why? Because I am taking s, top and n as a global variable. Fine. So again I am not passing x over there because I am going to take x inside the function. Let's see how. See, this is integer x, this is integer x. See, whenever you do not want to pass value parameter, then you need to take that value inside the function. If you want to pass parameter or as an argument, okay, of the function, then you need to pass that particular value at the time of function calling. Okay, this is the function definition, and I want to pass x inside the function, such like this, integer x. Then first check whether the condition is true or not. So if top is not equal to n minus 1, see, why I am taking this n minus 1 over there? Just because, students, just because if you check the algorithm, the index starts from 1, but in program the index starts from 0. Fine. So if I have stack with the size 5, then array ranges from 0, 1, 2, 3, 4. Again 0, 1, 2, 3 and 4. So such like the 0 to 4 is my array size. Okay, that's why I need to write in program like this. If my top pointer is greater than or equal to n minus 1, then just write printf stack is overflow, stack is full. Else what you need to do? First you need to increment the top pointer. But before that we need to take the value of x. Okay, so else first take the value, like enter the value, scan the value, and then increment the top pointer, top plus plus, and then assigning the value as of top is equal to x. So that's it for the C function of push algorithm. Fine. If you can see, isn't it easy, right? So let's move towards the next algorithm, that is known as pop. So students, the next algorithm is pop algorithm. So here pop is a function. Why it's a function? Because it returns something. As we know, when an algorithm returns something, it is known as function. It does not return anything. That means it's a procedure. Students, the pop, that means you need to delete the top element from top of the stack. Okay, so here the pop s comma top, that are the power parameters, and then s represent the stack. Top is the top pointer, which is pointing to the topmost element of the stack. So first here we need to check the underflow condition. Why? Students, when you are inserting something inside the stack, you need to check the overflow. When you are deleting something from the stack, you are going to check the underflow. Underflow checks whether my data structure is empty or not. Fine. So here it is, if the top is equal to 0, then write stack is underflow. Now the step number 2 is decrement my top pointer. So here, just suppose this is my stack, this is top pointer is pointing over here. If I want to delete something, then the top is decremented, and then I need to return the top plus 1 element. So before deleting elements, students, I need to set my top pointer. That's why I am decrementing the top. Write return as of top plus 1. Students, here see, this is a comparison over here. Whenever you write in a program like is equal to operator, that shows the comparison. Here in algorithm, the comparison goes like this: top is equal to 0. Fine. Now next is, see, this is our figure where we have 1, 2, 3, 4 and 5. So 10, 20 and 30, only 3 elements are there. That's why my top pointer is pointing at 3rd position. Students, this is my top. Now if I want to apply the pop operation, then what happens? Top pointer is decremented from top 30 to below 20. Okay, so now my top pointer value is 2 and the element is second index is 20. Fine. Top pointer value is 2 and element in second index is 20. So this is my top pointer position after deleting 30. Now the next, see students, suppose if I want to delete something again after deleting 30, this is my final figure where we can say the 10, 20 and are there. top pointer is pointing at 20th element. Okay, now if I want to delete again, now my top pointer is decremented and goes at 10. If I want to delete again, then the top pointer is decremented at 0 and there is no element are there in the stack. So this is my final figure. After deleting each and every element, you can easily say that now my stack becomes empty. So when my stack becomes empty, you can see my top pointer is pointing at 0. Now let's move towards the next point. Next is C function pop. Students, the pop function is like this. Here I want to return something, that's why it's an integer pop. Do not want to pass any parameter. Whatever the values I want to take, I will take inside the function only. So the first I need to check whether my stack is under flow or not. The condition becomes top is equal to -1. Here my condition becomes if top is equal to -1. Why it is -1? Students, remember in algorithm n index starts from 1, but in program the n index starts from 0. So when your stack is empty, your top is pointing at the -1 position. Fine. So now the next we have print stack empty. Next, return -1. Else, what do you need to do? First, you just need to decrement our top pointer. So here I am decrementing my top pointer goes like this, top minus minus, and then return s of top plus 1. Here, instead of return s of top plus 1, students, I assign the value s of top plus 1 to y and then return y. That is my logic. You can directly write return s of top plus 1. Why, students, returning s of top plus 1? I have already cleared, because whenever you decrement a top pointer, you need to return that particular, the previous top pointer element. So you need to increment one value over there. Fine. Now let's move towards the next topic. Our next function is peep. Here in peep, you are going to fetch ith element from the top of the stack. That's why I'm taking another parameter, that is I. So this function returns something, that's why it is function peep s comma top comma I. Now step number 1 is check for the underflow condition of the stack. Top minus I plus less than or equal to 0. Why it is top minus I plus 1 less than or equal to 0? We'll understand in this particular example. Okay, so now see, this is my stack, students. If I want to fetch first element from the top of the stack, it becomes 30. If I want to fetch second element from the top of the stack, see, this is my stack. Okay, top second element from the top of the stack, that is below the top, that is 20. Third element from the top of the stack, that is 10. Fourth element from the top of the stack, that is nothing, because only 3 elements are there. Fine. So when a top is pointed at 3, you need to fetch out the fourth element. Then the condition goes like this: top minus 4. I, that means 4. So top minus 4. Now tell me, what is the value of top? Top is at 3. Okay. So value of top is 3. 3 minus 4 becomes minus 1. 3 minus 4 becomes minus 1. But actually, what is your fourth value? Fourth value situated at 0 index. But you got answer minus 1. That's why you need to increment 1 over there. So my final condition becomes top minus I plus 1. Okay. So now if your element is there, top minus I plus 1, that is 0th index. Is there any element at 0? No element is at index 0. That's why you can directly write the stack is under flow. So before fetching or before applying the peep operation over there, you need to check whether my stack is under flow or not. Now step number 2. Step number 2 is return ith element from the top of the stack. How we can return ith element from the top of the stack? The ith element from the top of the stack, it is as of top minus I plus 1, because top minus I plus 1 is the index of the ith element, and what is the value at the particular index? That is as of top minus I plus 1. Fine. So that is your answer, return as of top minus I plus 1. Now next we have function for the peep. Here it is. It is returning something, that's why a function must contain integer as a return type. So integer peep, integer I. Here I am passing the variable I. Okay. So now integer I, which element do you want to fetch? Which element do you want to fetch? If I want to fetch ith element, then I need to scan the value of I. Okay. Now next we have if top minus I plus 1 is less than or equal to minus 1. That's a condition. Then right, no elements are there. Now that is nothing to fetch, else just return as of top minus I plus 1. Fine. So here it is. That's my answer. See, top minus I plus 1. Okay, now let's move towards the next function, that is change. So students, change is change ith element from the top of the stack, where procedure change as top, I and x, 4 elements are there. S represent the stack, top represent the top element or top pointer, I represent the index, ith index from which you want to change the value, and x is a parameter which we want to insert as a new value. Fine. Now again, it's a fetch the ith element or change the ith element from the top of the stack. So again you need to check the same condition, whether my stack is underflow or not. The condition is top minus I plus 1 is less than or equal to 0 or not. If is that so, then just write stack is underflow, else just assign the value, new value to x. See, here I need to assign the value to the particular position. So position is top minus I plus 1. The value is s of top minus I plus 1. So I need to write s of top minus I plus 1 arrow x. Fine. Now next we have the C function for this change. Next we have C function for change. Here we need to change the ith element from top of the stack. So the function goes like this. See, same as the peep, the function goes like, first we need to take the I value, then x is already passed as a parameter. Okay, check the condition. If top minus I plus 1 is less than or equal to minus 1, then there is no element to change. If is this not so, then just write s of top minus 1 plus 1 is equal to x. Fine. So that's it for today's lecture, students. Thank you so much.